So be sure your name is on the top. Today is 4/10. We do have a sub tomorrow and then 2 days of testing. So at the end of the hour, I am going to collect these because I don't know that I'm trusting you on Wednesday. You're in here. I'm not. I won't be in here, but Mrs. Wright will be in here. I don't have to proctor a test for like the next 10 years because I have a student taking it. The PSAT.
Also, like you're not allowed to do it.
Yeah, we're not allowed to be near any testing materials if you have an 8th or a 9th grader. So I have an 8th grader and then a 9th grader next year, and then an 8th grader, and then a 9th grader the year after, and then an 8th grader, and then a 9th grader the year after that, and then an 8th grader and a 9th grader the year after that, and then a 9th grader the year after that, and then I might have to do it for a year, and then I'll have an 8th grader and a 9th grader. Isn't that crazy? Crazy, all right. All right. So anyways, we digress, right? I would like you to read this page 1. And the reason I gave you a highlighter is because, yes, I'd like you to especially look at definitions of words that you think you're going to have to remember, key ideas, things like that. Because I need you, after you're done reading this, to understand the difference between a homologous structure and an analogous structure.
Homologous structure?
This is what you're reading about, right? So I'm going to give you some time to do that, and then we're going to talk about that, and then we're going to look at page 2.
Mr. Bailey's not here.
And then we're going to kind of follow that same process through this packet.
Detroit.
So what were some of the things you guys underlined? Andrew.
Evolution.
I mean, it's already bolded, so.
Well, it makes it even more.
But why did you underline evolution?
Because it's the study how organisms.
Okay, so the important thing that we didn't know was this right here, right? So hopefully you highlighted the study of how organisms change over time.
I did.
What else, Porter?
Anatomy is the study of interior structure of an organism.
All right, so we have anatomy here, and this is another study of the internal structure of an organism. Anatomy. So type of evidence is anatomical evidence, so that has to do with internal structure. Your anatomy, anatomy is something that you would take if you're interested in nursing or being a doctor, a physical therapist, dentist, all those medical fields. Even a dentist, they have to go through anatomy too. Yes.
I was gonna say next.
That's fine. Go for it.
Homologous.
Homologous.
Structures are very similar between organisms.
So remember, homologous. Remember when we were talking about our chromosomes or our genes? When we are talking about our genotypes, like when we had little l, or big L, those were homologous, right? Or homogeneous. That homo means the same. So the same structures look very similar between organisms. So this has to do with the looking very similar. Sometimes they serve different functions though. So here we're getting at how these two different things are different. So analogous means they have what? Analogous structures serve the same function, but sometimes look different. So especially this part is important. One looks similar, but may have different functions. One has the same function, but may look different, right? Human arm, bat wing. They look similar, structurally at least, right? but they have different functions. We cannot fly, regardless of how you want to argue with that, with our arms, right?
Yeah.
And then they took two different wings, even though they serve the same function, they look different structurally, right? So because an organism's genes determine its physical structure, homologous structures provide evidence that two organisms are closely related. Analogous structures do not. So this is another part I want you to be sure you have highlighted. Because this part, homologous structures provide evidence that two organisms are closely related.
Thank you.
Remember, homologous means they have the same. They look the same, but maybe have a different function. Okay? All right, so time to practice these things. Go ahead and on your own, look, are these homologous structures or analogous structures? Does their structure look the same or do they function the same? So homologous, maybe we should put look. I'm going to put two eyeballs here, right? Do they look the same or do they function the same? I can't think of a fun doodle to do for function, but maybe you do. So answer 1, 2, 3, 4, 5, 6, and try to answer number 7, okay? So remember, we're talking about look or function. If they look alike, stop right there. Pick homologous. Are you ready? Number 1, what'd you say? Homologous. They look.
They look. Oh, it's homologous? Oh, I got it.
Homologous. Look at their structure. Looks the same.
On the first one.
Oh, wait, we're on.
Oh, yeah, on the first one. What are y'all talking about? Yeah, I got homologous.
Yeah, homologous.
All right, number 2, what'd you say? Same thing?
Analogous. And not they function the same.
I got the homologous.
They function the same but look different.
They look different?
Analogous.
I would call it homologous.
Yeah, homologous.
I picked them out.
They may or may not function the same. How about that?
I picked one, but then I tossed it out because I realized it was wrong.
So, all the same. Ladies.
Next one, analogous.
Analogous?
Analogous.
I would agree. They have the same function, but different structures. Same with number 4, they're analogous. They have the same function, but different structures. Very good. Number 5 is analogous.
Yeah.
It's homologous.
And number 6 is homologous. Yep.
Wait, so the first 2 are analogous? Homeless.
3, 4, and 5 were analogous. The rest were homologous. All right, think through number 7. Listen carefully. Which organisms are more closely related? The whale and the shark, or the whale and the bat? Explain how you know. Use what you learned in the problems above and include the terms homologous and analogous in your response. So we're answering the question. Either you're going to say the whale and the shark, or you're going to say the whale and the bat are more closely related because their structures are homologous. Do they look the same? Maybe they're also analogous. They have the same function and they look the same. I don't know. Write those things down. Think about it. Because maybe you might say just because the whale and the shark have analogous structures, we find what? What did we highlight on this first page? We find that homologous structures provide evidence to see what when they're closely related, so not the analogous. So here's how I would answer. First of all, which was your answer? Did you say the whale and the shark or the whale and the bat? You should not have said the whale and the shark. You should have said guys, this is supposed to be made for kid movie, so keep it PG here. The whale and the bat are more closely related. Do you see so far? This comes directly from our question. Are more closely related than the whale and the shark. So when we were comparing in number 1, right? We're comparing the whale and the bat in number 1. We said these were homologous. So the whale fin and the bat wing are homologous. And the bat wing are homologous structures. Whereas the whale fin and the shark fin are analogous structures. The other part that you should probably share is that homologous structures show closer relation. I know that's a lot. I know that's a lot because we're writing in full sentences and answering the questions completely. This phone number has tried to call me twice now.
Answer it.
So the whale and the bat are more closely related than the whale and the shark. So just because they look, you know, would you have looked at a whale and a shark and been like, yeah. But you've actually closely study their anatomy, their structure of their insides, you would see that the whale fin and the bat fin actually have the same structure, meaning they're homologous, whereas the whale fin and the shark fin are analogous structures. So even though they have the same function, we find relatives by looking to see if their structure is the same, not if their function's the same. Okay, so again, on this first page, be sure that you underline this part. It's very important. Homologous structures provide evidence that two organisms are closely related. So far, so good? All right, we're gonna do the same thing, but we're gonna start now on page 3, where it says homologous, analogous, and vestigial. So now we're adding a new structure here. So again, use your highlighter, review, and not review, but read and highlight things that you think are important so that you can use that on the questions momentarily.
Not harder tape.
All right, analogous structures. You can define that now, right? Yes, exactly. Analogous has to do with function. Same function, similar function, different look, right? Different structure. It's more intelligent. I don't know. What type of evolution do you think typically illustrates analogous structures? Explain convergent, divergent, coevolution. So we have to figure out, hopefully you've highlighted a few important things about convergent, divergent, and coevolution. Converge. Think about what it means to converge. When you converge with something, there's multiple things coming together into one, right? So the process in which two different lineages evolve a similar characteristic independently of one another. So this often occurs because both lineages face similar environmental challenges and selective pressures. Divergent evolution is the process in which one common lineage evolves due to differences between species, and that can lead to the formation of new species. It is typically a result of genetic drift and natural selection. So if something, natural selection is like when something kills it all off, obviously that part of them did not help them survive. So those that were weaker may have died, per se. Okay? Coevolution, two or more species reciprocally affect each other's evolution. So coevolution is likely to happen when different species have close ecological interactions with one another. So pick an animal and think about how they might kind of resemble each other and why they might resemble each other. Things that live near each other. I don't know, like deer and antelope, right? Sometimes they're hard to tell apart. Deer and reindeer. Moose. You don't typically see a moose in the lower peninsula, right? They're more built stronger for hardier weather in Canada or in the upper peninsula, right? So just think of what may have made that more prevalent there than down here. So what do you think typically illustrates analogous structures? So remember, this is something they have a similar function to. So do you think two lineages evolve a similar characteristic? So maybe when we go back to the question we just answered last, we're talking about a shark and a whale. They have analogous structures, right? They could have come from two different lineages. You think it's divergent because one common lineage evolves due to differences between species. So essentially, if they wanted to survive in the water, they both needed fins, right? I can go there. Like, as long as you're thinking through and how you would back that up. I know this is a little tricky. I wouldn't say either like, yes, has to be one right answer for some of these, which is, I know why some of you don't like it. The math brain in me doesn't always like that either, right? There's always one right answer. But here you could argue either. Homologous structures. This one is kind of backwards, right? Similar structure. Now, I wouldn't say definitely a different function, but it definitely could be a different function, right? Because like my arm or my hand and a bear's hand would be homologous structures, right? So I would call them homologous, even though they probably have fairly similar functions as well. Does that make sense? So if it's not homologous, it's probably analogous because they use the same. What type of evolution do you think typically illustrates homologous structures? So how do you think we ended up with similar structure but different? So you're thinking divergent and then... Okay, so were you thinking convergent here? You're thinking convergent here. I gotcha. Okay, I could see that for sure too. So two different lineages, they came from two different places, so they have different structures. Evolve. See, I think I would probably go convergent here. Because when you think about this, think of two different lineages. They wouldn't have the same structure, right? If they come from two different lineages, but they might have to use them the same way. So they have similar environmental challenges, like being thrown in the big sea, right? So I would probably say convergent here. Divergent, common lineage due to differences between. So they start with the same structure. Am I thinking of this backwards? No, I think. So they start with the same structure, but then they spread apart, so they might have a different use for that same structure. For instance, you have a tailbone, right? Monkeys have that similar structure, but obviously we use it for two very different things. So here I would say divergent, and vestigial we'll find are a little bit different. So we need to figure out what vestigial structures are. Did anybody? I don't know that they even defined it here. All right, let's look it up together. So we're going to look up vestigial structures. Let me share screens with you. Dun, 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 dun. All right, I love a good picture. A vestigial structure is an anatomical feature or behavior that no longer seems to have a purpose in the current form of an organism. So wisdom teeth, we don't really need anymore. I'm really not sure what Goosebumps has to do with it. I'm sure it means well. Appendix, you can survive without it, right? It doesn't, we don't need it. So a vestigial is kind of there, kind of like our tailbone, right? You might even say that's a vestigial structure, right? Yep. So it's an anatomical feature or behavior. So a behavior like goosebumps, we don't really need to warm ourselves with our goosebumps anymore or scare off people. Like think about what am I trying to say? What are those? The quills. Porcupines. Thank you. Think of porcupines. Their goosebumps when they get scared, zoom, shoot at you, right? Or they prick up like goosebumps do. Our goosebumps aren't really scaring anybody away from us, right? Or protecting us from predators. So that makes a little more sense when we think about anatomical behaviors.
Appendix, we don't need an appendix. What's an appendix?
Yeah, what's an appendix?
An appendix is like the add-on to a story. No, it's just part of your body that we don't really use
What happens,
anymore.
like when you have like a appendix first?
Oh, they just cut it out of you.
What does it do?
Anna Klein's dad's appendix burst last week, and they had to do emergency surgery. And the worst part was, had they have gotten it sooner, you know, that especially when it burst, the infection got all over him. So they had to keep him in the hospital longer for observation and to be sure they killed all of the infection before they sent him home. But a lot of times when your appendix is infected, it hurts so badly. Like, obviously, Mr. Klein's a pretty tough guy, apparently, because he didn't do anything about it until it was too late. But thankfully, he's okay. They caught it and were able to do the infection, and he's home now. But that's scary stuff.
What do you mean wisdom?
I would guess like grinding different food, eating different things that we don't really need to anymore. Yeah, maybe, but doubtful. All right, so questions about vestigial structures. So can you see where we might, how do I, that was weird. I wasn't sharing that whole time. Well, there's that for the video, people, if you need that. So pause it there and think about those things. Otherwise, we're gonna look here at our last question. What types of evolution do you think, this should say vestigial, so go ahead and cross this out. So vestigial, something that we don't need anymore. I mean, maybe more co-evolution. I don't know. I think that one's tricky. But we'll think about that some more too, and I feel like we'll come up with a better answer. As we always do, of course. All right, questions, concerns about these? Please be sure your name's on them, turn them to the front, either tuck them safely away in your notebook or I'll take them because we won't be using them till Friday. You can set them right there in that book, please.
Everything does.
I think so.